Flow control is simply a series of statements which can decide which instructions to execute and in what order. For example, if our program execution starts here at the top, we can create a variable named count. And the first thing we can do is check and see is count greater than 5. And if it is greater than 5, then we can end our loop and move forward to the next section of code. If it's not greater than 5, then we can do some stuff. We can get login information, we can execute the show version command, and then at the end we can increase the value of count by adding 1 to it. And then once we get to the end of our loop function here, we'll come back to the top and check the value of count again. Now when we do this, we have some things we call Boolean values, and Boolean values are simply just a 0 or a 1. And we can represent them with the keyword true or false, and it has to be a capital T or F. A lowercase t or f will not register as a Boolean value. You can't use quotes, and because these are reserved words, capital T, capital F for true and false, you cannot name a variable either capital true or capital false. Now with comparison operators, this is what we're going to do to check some type of condition. Now since we use the equal sign to assign a value to a variable, we have to use two equals to check and see if something is equal to. If we want to see if something is not equal to a value, we use what they call the shebang, or the exclamation point followed by the equal sign. Less than and greater than are pretty simple, and then less than, equal to, or greater than equal to. We start with the greater than or less than symbol, and then the equal sign. So let's take a look at some of these comparison operators in action. And in just the Python interactive mode, we can check and see if 12 is equal to 12, and it's going to return and say true. And then we can check again, 12 is obviously not equal to 13. If we want to see if 21 is not equal to 12, then we can use the shebang, and then we have less than equal to operator. And then also if we want to compare strings together, we need to remember that when we verify strings, we're going to be looking at the case also. So hello world lowercase is not equal to capital H in hello world. And once again, I want to remind everybody that the double equal symbol is checking if they are the same as each other. This is used for comparison. And the single equal is assignment. This is what we use when we assign a value to something else. So we have some Boolean operators, the and, or, and not, to compare Boolean values. So how this works is if if two values are both true, then the result is true. But with the and function, anytime you don't have both values in your expression equaling true, then you'll return false. And here is the same expression using binary as opposed to true false. Now the or function returns true if either value in the expression is true. So in this example, true and true equals true because one or the other is true. True and false returns true. False and true, anytime I see true, I meet the or condition. But only when I receive two falses do I return a false. Now this is an example of the AND function using for determining the network address of an IP address. So if we take the IP address and we put it into binary, and then we put the subnet mask in binary as well, if we AND the IP address to the subnet mask, we're going to return the network address. Now let's take a look at how this works. Remember, in the AND function, anytime I AND something to a 1, so these two examples right here, the top two examples, I'm going to actually return the actual value of the second value. So ANDing to 1, if I AND a 1 to a 1, I get 1. If I AND 1 to 0, I get 0. Now anytime I AND to a 0, I'm going to get 0. And if you remember, a network address is when all host bits are set to 0. And the network portion of the address is untouched, and that's exactly what happens here. anytime I AND a value to 1, I get the original value, 1, 1, 1, 1. All these zeros here, they all become represented as zeros here, all the way across. So anytime I AND to a 1, I actually get the actual original value. Anytime I AND to a 0, I'm going to set everything to 0. So all of these host bits, 0, 1, 1, 1, 1, 0, 0, doesn't matter. We're setting all the host bits to 0 without changing any of the bits in the network address. The network address is unchanged. So conditions. Conditions is a more specific form of an expression used in the context of flow control statements. A flow control statement decides what to do based on whether the condition is true or not, whether we meet a condition essentially. Now let's talk about code blocks. Code blocks are lines of code that can be grouped together as blocks. You can tell when a block begins and ends from the indentation. The indentation is very important in Python. It takes a little bit of getting used to, but once you get the hang of it, it's not so bad. Blocks begin where the indentation increases, and blocks can contain other blocks. Blocks end when the indentation decreases to 0 or to the containing block's indentation. So let's take a look at some examples of that. For this example, we have everything. We're starting with our indentation at 0. We're using the input function to ask for you to enter your name. And then we also use the input function, and we're going to convert that to an integer, because remember, anytime you use the input function, you're going to return a string. And then we're going to get an age. Now we have some code blocks here. Let's take a look at these code blocks in a little more depth. Each highlighted yellow square shows examples of code blocks. For example, if this condition is met, if the age is greater than 15, then we're going to execute this code block starting at print where it's indented. And then once again, if age is greater than or equal to 18, then we're going to execute this code block. And then once we get through all of the code blocks and we go back to indentation at 0, this executes, but it only executes after any or all of these above code blocks have finished. An if statement is the most common type of flow control. If a condition is true, we can do something. The condition statement is ended with a colon. You need the colon right here to tell Python that you've created an if condition. And then after you have the if condition, Python is going to expect the next line of code to be indented. The else statement, the else clause, is executed only if the if statement's condition is false. Else statements do not have a condition. The elif statement always follows an if or another elif, and this condition is checked only if all previous conditions were false. So in this example, if age is greater than or equal to 21, if this is met, then these two code blocks are ignored. If this is false, and if the elif age is greater than 18 is false, then this one will execute. Loops are a way to repeat code over and over again. A loop makes a code block execute repeatedly. A while loop repeats if a condition is true. Components of a while loop include the while keyword, a condition check, of course you need the colon, and an indented block of code to execute while the condition is true. When the while clause finishes, execution returns to the condition statement. So let's take a look at creating a while loop. Here's 3 examples of while loops. In the first condition, we're going to set a variable, and we'll just call it x for simplicity. And while x is less than 11, we're going to add 1 to x and print it. So the first time this executes, at line 2, x is initially equal to 0. We add 1 to it, we print it, and then we go back to line 2. In the second example, if we print x before we increment it, the first iteration of this loop is going to be 0. X will be 0 when we print it. and then we increment it. So in the condition while x is equal less than 11, 10 is less than 11, we print 10, then we add 1 to it, and then we go back to our condition check, and now x is equal to 11. In this example here, the third example, while x is less than 10, we're going to increment x, and then we'll print it. And as you can see, we're counting 3 different ways in printing. In the first example, we count from 1 to 11. The second example, we start printing out output at 0, and we stop at 10. Because when x gets to 11 here, the loop terminates. And then in the third example, we start at 0, we increment it, and then we print x. So the first iteration, 0, increment, so now x is 1, now we print it. So we start counting at 1, and when x gets to 10, we stop or we terminate the loop. Break statements are the shortcut to exit out of a while loop's clause. Execution immediately exits the loop if the break statement is reached. So what this means here is we have a while loop, and while x is less than 1,000, we count, we increment x, we print it, but now we have an if statement here. If x is equal to 10, we're going to break, and that exits completely out of the loop. So as soon as x is equal to 10, notice we print x first, and then we check to see if it's 10. And if it is indeed equal to 10, we break out of our loop, and then we go to the next line of code with no indentation. Now the continue statement is just the opposite of a break statement. The continue statement is going to execute, it's going to return to the beginning of the loop. So while true, that simply just pretty much is an infinite loop. It's going to keep running until you break out of it. So in this example, we use the input function to ask the user to input a password, and we can check it. If name is equal to this, we're going to break, and then we're going to skip ahead to the next line of unindented text. Now if name is not equal to this, then we're going to execute the else condition, and we will continue on, which continue means not continue to the next line of code. Continue means return to the beginning of our loop function. The for loop executes a predetermined number of times and includes the following: the for keyword, a variable name, the in keyword, and a call to the range method, as well as a colon and an indented block for the clause. Let's take a closer look at the range function. The range function returns a sequence of numbers. It starts at 0 by default, increments by 1 by default, stops before the specified number. So in this example, we create a variable called x, and it's going to be equal to the range of 6. And remember, it starts at 0 by default. We don't have to specify 0-6 or anything like that. If I want to print the x, we can see it right here, and it's going to just be represented by the string here, range 0-6. Now if I want to do a for loop for the range of x, I can say for n in x. N is just another variable, and when I print n, I'm going to execute this loop 6 times, starting at 0. When I get to 5, that's the last iteration of it. When I get to 6, the loop stops, and I'm just going to print the value for n. So if we take a deeper look at the range syntax, we have a start point, a stop point, and a step. So the start point is optional, and it's an integer number specifying at which position to start. The stop point is required. This specifies when we stop the range, the end of the range, and the step is an optional. If by default my step is going to be 1, if I want to increment by evens, for example, if I want to return all even values of a range, I could step by 2, I could count by tens, whatever I want if I want to include the step. And remember, these 3 values have to be comma separated, and they can be integers or they can be variables if the variable contains an integer. So here's a for loop that we've done. For x in range 10, so this loop is going to execute from 0 to 9. and then I'll create another variable called num, and that's going to be equal to 2 raised to the power of x. So the first time this loop executes, x will be equal to 0. The second time x will be equal to 1, x is equal to 2, and I can go ahead and print this out each time we take x, and each time we take 2 and we raise it to the power of x. Now if I want to count negative numbers, I can go from x in range, or that's just counting backwards. Now if I want to count backwards from high to low, I can set my start point as a high value, my stop at 0, and I can count by changing my increment to -1. So in this example, 2 to the power of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Modules and packages. A module is a set of related codes saved in a file with the extension of .py. Packages are a directory of a collection of modules. Packages allow the hierarchical structure of the module namespace. It's really kind of just a group of modules is how I think of it. A library is an umbrella term referring to a reusable chunk of code. Usually a Python library contains a collection of related modules and packages. The term is often used interchangeably with Python package because packages can also contain modules and other packages. However, it is often assumed that while a package is a collection of modules, a library is a collection of packages. Python has a basic set of functions called built-in functions. Print, input, and length are all built-in functions. Python also comes with a set of modules called the standard library. Before you can use a function in a module, you must import the module with the import statement. This is for the modules that don't come as part of the built-in functions. So if I want to import a module, there's really 2 ways you can do it. I can import the entire package or library right here, but if I want to be a little bit more specific, I can, well, if I do it this way, I can't just call the random integer function. And the reason for that is it doesn't know that the random integer is in the random module. So if I want to use the random integer, I have to say random dot, basically the module name, and then the function. If I import it and tell it where random integer is, randint, by using from module name import function, now I only have to specify the function name each time.